Hey everyone, welcome back to the channel. Today we're diving into a super cool project, a 3D block stacking game built with JavaScript and Three.js. You've probably played something like this before. Stack blocks as high as you can and don't let them fall. In this video, I'll break down every single line of the code, explain why we're using it, and what each value means. By the end, you'll understand how to create this game from scratch. So grab a snack and let's get started. It's a standard HTML5 setup. The meta, tags handle encoding and make it mobile friendly with user scalable no to lock zooming. Title names it tower blocks, and we link our CSS. Inside body, container holds everything. Game is for the Three.js canvas. Score shows the score starting at 0. Instructions tells you how to play. Game over pops up when you lose with a title and messages. Game ready has a start button and a spacer div. We load Three.js for 3D, GSAP for animations, and our game.js script. We import the Comforta font for a playful look, then we reset margins, hide overflow for a full screen game, and set the font. Score sits near the top, centered, with a big 10 VH font. It starts hidden above the screen and animates with transition. Container fills the screen, and game overlays it completely for the canvas. Game over covers most of the screen, using flex to center its text. Everything starts hidden and shifts up, with H2 at 40 px. Game ready fills the screen, spacing out the button and spacer. Start button starts hidden with the border and big text. Instructions sits 16% from the top, centered and starts invisible. Hide keeps it hidden when needed. These rules tie into game states. Playing and resetting show the score. Playing reveals instructions. Ready shows the start button. Ended moves and scales the score. Reveals game over text with a slight delay on P tags. Alright, here's the stage functions, our foundation for the 3D environment. Let's break it down. First, we grab an HTML element with the ID game. This is where our 3D canvas will live. Think of it as the stage where all the action happens. Next, we create a WebGL renderer. This is what draws our 3D scene to the screen. Anti-alias. True smooths out jagged edges, and alpha. False means no transparent background, we want a solid color. Set size makes the renderer fill the browser window.inNerWidth and window.inNerHeight give us those dimensions. Set clear color sets a light gray background. The one is the opacitively opaque. Then, we append the renderer's DOM element, a canvas, to our game container. The scene is like a 3D world, where we'll add objects, lights, and cameras. Simple, but essential. Now, the camera. We're using an orthographic camera instead of a perspective one. Why? It doesn't distort objects with distance perfect for a stacking game where we want consistent sizes. Aspect is the width to height ratio of the window. D is a zoom factor, 20 reals units gives us a nice view. The parameters define the left, right, top, and bottom edges of the view. -100 and 1000 are the near and far clipping planes. Anything outside that range won't render. We position the camera at 2, 2, 2, a diagonal angle above the origin, 0, 0, 0. Look at points the camera at the origin, where our blocks will stack. Lighting. A directional light shines white light 0x parf, with 0.5 intensity, half strength. It's positioned high above at 0, 499, 0 to simulate sunlight. We add it to the scene. An ambient light adds soft, even lighting, 0.4 intensity, so there are no harsh shadows. It's also white and goes into the scene. Finally, we handle window resizing with an event listener that calls on resize. We also call it immediately to set things up. Let's look at the stage methods. This moves the camera vertically as a stack grows. Y is the target height, and we add 4 units to keep it above the block. Tween light, to animates the position and look at over speed seconds. Default 0.3, with a smooth power 1 ease in out curve. On resize, we update the renderer size and adjust the orthographic camera's view. View size, 30, controls the zoom smaller values zoom in. We recalculate the camera's boundaries and call update projection matrix to apply the changes. Simple but critical. Render draws the scene using the camera's perspective. Helper methods to add or remove objects like blocks from the scene. Now, the block class where the game's core logic lives. Each block has states: active, moving, stopped, placed, or missed, fell off. Move, amount 12. is how far it moves side to side. Dimension and position track size, and location. Target block is the block below it, or null for the first block. Index is the block stack order starts at 1. Odd indexes move on the x-axis width, even on z-axis, depth. New blocks inherit size from the previous block, or default to 15 times 3 times 15f, or the first one. X matches the block below, or starts at 0. Y stacks blocks vertically. Z aligns with the previous block, or starts at 5. That's it. Keeps the stack neat and tidy. Colors. The first block is dark blue, 0 times 333,344. Others use a sine wave formula to create a gradient effect based on index and a random color offset. Values are normalized 0 to 1 for Three.js. The first block is stopped. Others start active. Speed increases with height, but caps at -4 for playability. We create a box with box geometry, shift it so the origin is at the bottom left, and apply a tune material for a flat, cartoonish look. This line puts the block's 3D mesh at its X, Y, and Z positions. The Y plus this state equals this. States active, 0 to 0 part checks if the block is moving, active. But here it adds 0. Either way looks like a placeholder for future tweaks. If the block is active, this sets its starting spot on the working plane, either X or Z. Math, random, 0.5 flips a coin heads. It goes left or back. Move, amount, which is -12. Tails, it goes right or forward. Move, amount, sure. This kicks off the block's side-to-side motion. Let's tackle the block methods. Flips the block's direction when it hits the edge. When placed, it stops. Overlap calculates how much this block aligns with the one below. This object stores info to send back like which plane, X or Z, and the block's direction. If the leftover piece is tiny, less than 0.3, it's a perfect stack. We set overlap to the full size, mark it as a bonus, and match the position and size of the block below. If there's any overlap, we split the block. Chop dimensions is the part that'll fall off, shrinking by the overlap. The block keeps the overlap size. We make a new 3D shape for the part that stays, shift it so it's positioned right, and turn it into a mesh. Same deal for the chopped off piece of new shape, shifted and made into a mesh. We set positions. The place part snaps to the lower block if it's off to the left or back. Otherwise, the chop part shifts over. The meshes get their spots, and we add them to block's tool return. If it's not a bonus, we include the chop piece. No overlap, it's miss game over. Finally, the block size shrinks to the overlap, and we return the info. This handles stacking or falling. Let's check out block. Prototype, tick this, makes the block move. It only runs if the block is active, meaning it's moving. Value is the block's position on its plane, X or Z. If it goes past move amount 12 or move amount 12, it calls reverse direction to flip its path. Then it moves the block by adding direction, a small speed like -0.1, and updates the 3D mesh to match. This keeps the block sliding back and forth until you place it. Let's start with the game constructor. We kick off by defining game states in an object called states. These are like labels for what's happening. Loading when it's initializing, playing during active gameplay, ready before starting, ended when you lose, and resetting when restarting. These strings will also match CSS classes for styling. This keys is an array to store all our block objects, like a history of every block in the stack. It starts empty. This state tracks the current game state, beginning with loading since we're setting things up. Here, we create a new stage instance. Remember, stage handles the Three.js scene, renderer, camera, and lights. This is our 3D playground. Now, we grab HTML elements by their IDs. Main container is the main div wrapping everything, used for state-based styling. Score container displays the score. Start button is for starting the game, though not used much here. Instructions shows gameplay tips. We set the initial score to 0 by updating score container's HTML. These are Three.js group objects. Think of them as folders. New blocks holds the currently moving block. Place block stores all successfully stacked blocks. Chop blocks contains pieces that fall off when you misalign. We add these groups to the stage's scene using the add method we defined earlier. This makes them part of the 3D world. Add block creates the first block. We'll detail this method soon. Tick starts the game loop, updating and rendering continuously. Once setup is done, we switch to the ready state, signaling the game is ready to start. This listens for key presses. Key code == 32 is the spacebar. When pressed, it calls on action to handle the input. Same deal for mouse clicks and e-click triggers on action. This makes the game playable with either input. For touch devices, touch start prevents default behavior, like scrolling, ensuring smooth gameplay. Next, the update state method. This switches the game state. The for.in loop removes all possible state classes, like loading, playing, from main container. Then it adds the new state's class, for example, ready, and updates this. State. This syncs the UI with the game logic. Now, onAction or input handler. This uses a switch statement to decide what happens when you click or press space. In ready, it calls start game to begin. In playing, it calls place block to stack the current block. In ended, it calls restart game to reset. Each case ties an action to the game's current state. Here's start game. This only runs if we're not already playing. Avoids double starting. It resets the score to 0, sets the state to playing, and adds a new block to kick things off. Now, restart give me a big one. Starts by switching to the resetting state. Old blocks is the array of stacked blocks. Remove speed, 0.2 seconds, is how fast they shrink, and delay amount, 0.02 seconds, staggers the animation. The loop animates each block shrinking to 0 size and rotating slightly, y 0.5 radians, with tween light. The delay makes it a wave effect from top to bottom. Once done, the block is removed. Camera move speed calculates the total animation time. The camera moves back to y2 over this duration for a smooth reset. This animates the score counting down from the stack height to 0, updating the display each frame. Keys is trimmed to just the first block, and after the animation, in milliseconds, start game restarts the game. Next, place block. Grabs the top block and calls its place method, which returns an object with placed and chopped meshes. Removes the moving block from new blocks, adds the place part to place blocks and the chopped part to chopped blocks. Position params makes the chopped piece fall 30 units down. Rotation params adds random spins based on the plane, X or Z, with a slight Y rotation. Adjusts the chopped piece's horizontal movement based on its position relative to the placed block, then animates it falling and spinning. Adds a new block to keep the game going. Here's add block. Checks if the last block was missed, if so, ends the game. Updates the score stack height minus the base block, creates a new block, adds it to new blocks, and stores it in keys. Moves the camera up, 2 units per block. Hides instructions after 5 blocks. Sets the state to in dead when you lose. Updates the top block, renders the scene, and loops with request animation frame for smooth animation. Creates and starts the game. We've built a 3D stacking game with Three.js, featuring moving blocks, chopping mechanics, and a dynamic camera. Share your thoughts about the project in the comments. Don't forget to like, subscribe, and hit that bell for more coding tutorials. See you next time.